Hello everyone and welcome. In this video we're going to talk about what the Simplex library is. So first of all, my history with C++. I have been working with C++ for quite a long time. It's been about 20 years now. I always enjoyed C++ with the idea that you have these classes and polymorphism and all of these high-level concepts, but that it compiles all the way down to binary that the computer itself can understand. I used to just always think that that was the coolest thing ever. There's not an interpreter in the mix. I Granted, at a young age, I thought that the code actually went straight to binary and that was like the best you could do. That was long before I learned about assembly and that there are even lower level ways of doing things. But like the XKCD comic jokingly says about the only real programming is using butterfly or something to alter the cosmic rays of a hard drive or something. Yeah, that rabbit hole is definitely one that I've probably gone down. Um, and that can get interesting when you start to get to the point where you're desiring to pulse electrical signals into a chip to program it. Um, so anyway, that's a tangent. Don't know exactly how we got there, but yeah, so that's me. I enjoy digging into the low level, definitely. And I took through my job experiences, I have experienced some of the higher level languages of JavaScript and PHP. Granted, those are interpreted or scripting languages. I've worked with Java to an extent, C Sharp. And when working with those languages, I just really enjoyed the tooling of them. The fact that it, when combined with, in the case of C Sharp, with Microsoft's IntelliSense or any sort of auto code completion and notifier of what you're doing, it was just really super intuitive. And there were aspects of that I appreciated, especially when I needed to get work done quickly. Then coming back to C++, I knew I could do all the same types of things, but it definitely was more challenging. There wasn't that intuitive level of, oh, you just do this and it just works, which is funny because in C++ things just never just work right out of the box. You have to fiddle with them, which I have definitely enjoyed that aspect of it in the past, but my goal was to find a way to not force everyone to do that if they wanted to experience the other fun parts of C++. Now, if you read about C++ online and you compare it to, I guess, let's say C Sharp, since C Sharp is a language that has taken aspects of C++ and applied it to its syntax and things like that, that people will say, oh, just write all of the high-level code in C Sharp and then use COM to talk to C++ or things like that. Have these people worked with COM? Because my experience with COM is it's kind of a living nightmare. So I avoid COM at all costs. And granted, also, C Sharp is a Windows language. You can use that Mono framework, which now I think has been taken over by Microsoft, and they're making a Linux version of that kind of stuff too. But if you want to interact with C++ with using C Sharp, I just imagine that not being an enjoyable experience. Java or other high-level languages, I'm sure there's ways to do it. I haven't run into it in the wild because necessarily if you're working with those languages, you usually want to work with one language from what I've seen in the industry, and it just makes sense to me intuitively as well. I'm sure there's people that disagree with that, But anyway, with that in mind, I wanted to try to make C++ easier for me and or others if they wanted it. So that's basically what the Simplex library is. It is the tooling of higher level languages brought into C++ or the C++ realm, I guess you could say. And there's different features that you will see shortly with automatic memory management and things like that. But anyway, that's just kind of a brief rundown of why this exists and a little bit about my history with C++. For the library itself, or the toolkit itself, it is licensed under BSD. Currently, someday that might be MIT, but it will not be GPL or LGPL or one of those licenses. I personally do not like those licenses. I do not need to start a holy war or anything on that with these videos. There's people that love them, that you need them, and I'm sure they probably have 100 different reasons. I personally just try avoiding them anytime a license says you have the freedom to do anything you want as long as we want you to do it, which is posting all of your code and not statically linking, and there's other things, and I know you can statically link as long as you show your code and you make your code the same license that they have and all of that. And it's sort of like buying a printer and then being told, oh, it's a real cheap printer, you can do anything you want, and then you got to pay us tons of money for the ink. There's a company that does that. That's my personal opinion about the GPL license, and a lot of basically all the copyleft licensing. However, I don't need to get into that. All I need to say is that this is BSD licensed, or maybe in the future it might even be an MIT license, which means you can take the code and you literally can do anything you want with it. You don't need to change the licensing on your code. You don't need to, you don't need to do anything. You can just use it. So I wanted to make it as accessible for everybody, where you didn't have to read through pages of licensing terms all written in legalese and all that kind of fun stuff. And now let's go to the most important part, which is actually, what does this library do? Now, this is where it is currently. I would not necessarily recommend it be used for production purposes. It is relatively stable. There might be some classes that are still a little rough around the edges. So it's a use at your own risk, and that is included in the licensing, that there is no warranty and all that other stuff in large capital letters. So, that is one freedom taken away from you. You cannot come after me. All right, so the library itself, I might kind of bounce around these because there is a little bit of a tree structured to them. Everything derives from object, and the reason for that is, so if you have a container of some sort, you can say that you want to store objects in there. You can stick anything into that container. And the other thing that object provides for you is it automatically includes the ability to support signals. And the signal and slot mechanism, I believe, was originally designed by the people of the Qt framework. If you're coming from the Microsoft world, this is going to be your events and delegates, signal slots, events, delegates, anything that uses kind of that observer pattern. And let's see, that's going to come from signal. So basically, it's a template. So there's all the code. That's all of it. I will have another video that covers how the signal slot mechanism works and the cool things you can do with that. But anyway, just know that if you inherit from objects, you will get the ability to work with signals and slots. Let's move to the top here. There are arrays. Arrays are one-dimensional arrays that you can work with that have a little bit more brains behind them besides just memory slots that you would normally work with in C or C++. And when you work with the arrays, you can add things, remove things, push things, pop things. They're all built on top of vector. So that was another design goal, is to not completely reinvent the wheel. The Simplex Toolkit is built on top of the standard library of C++. So as new versions of C++ come out, it will automatically get those benefits. So if they find a memory leak somewhere in their library and they push it out to the world and it's fixed, if I am built on top of that, that memory leak is fixed. And then that way I'm also not writing, there's rather complex code in the standard library to make sure that the memory is managed and that things don't get lost. And I would rather not reinvent that wheel. A lot of people use the standard library. If you are forbidden from using the standard library at a company that you work at, you're probably not going to be using this library either, because you're probably writing all your own code from the ground up. So that was a design goal as well, to build on top of the standard library. But anyway, that's the array. Then there's also a console class. What the console class allows you to do is interact with the console. Surprise, surprise. So what you can do is you can prompt a question where you can write out what you're looking for, and it will return a string for you. And I should cover strings next. You can read in a number of characters. You can read in a line. You can write out a line. You can write out an error line. So when you do write line or write, that's going to go to your standard output. When you do write error line or write error, that's going to go to that error output. The name slips my mind, but hopefully you know what I'm talking about. The string class. Yes, the string class is always a heavy lifter. It does a lot of stuff. And it allows you to bring in values that are numbers, automatically puts them into a string. It's built on top of standard string. And since it's using the standard library, all that cool stuff comes along, but it also includes things to make your life easier. To lower, to upper. You can export it out as a standard string. If you're working with a C library, you can put it out as a C string. You can get its length. You can find the index of a certain substring. You can do substrings as well. You can trim spaces from the beginning, the end, or trim will do both sides. You can also join them, where you can take an array as an input with a divider and export it as a string. So a lot of cool features there. All right. The other thing we should talk about are streams. So there's a stream reader and a stream writer class. Both of these are virtual classes or abstract classes, depending on which world you're coming from. Which means that they themselves do nothing. They are just basically a footprint saying that any class that derives this class needs to fill in the blanks. So, for instance, let's say, and obviously StreamWriter is the same way, where you have to fill in these values. So let's say you want to work with XML files and you want to play with the XML writer. You'll see that the XML writer requires that you put a stream writer into it. So if you want to, say, create an element and or a tag or whatever you might call it, you say, I want to create an element. If your stream writer is a console writer, it will automatically write all of this to your screen. So it will dump the XML out on your screen. If you change that to a file writer, it will write it to the file. If you do it to a string writer, it will write it to a string. This shouldn't be super new concepts, but in C++, I don't see this too terribly often. It's used in a lot of the very high-level languages. So if you're only having a C++ background, well, you might think this is sacrilegious, but yeah, it's at least handy in my opinion. In the future, I would love to have a socket reader and a socket writer, so you can automatically do writing of data over like a TCP or a UDP connection. So that might be coming eventually. Like I said, this is under active development, so the things you see here may get added to or deprecated or things like that. Database is specifically an abstract class for some of the other extensions I'm working on. There's a SQLite extension that is under development so that you can basically say, I want to connect to a database, and when you want to work with that database, or if you want to create your own classes using this abstract methodology, if you stick in a SQLite database, you can do all of the things that you want to do with that database. If you sub out SQLite for, let's say, MySQL or MariaDB or Postgres maybe in the future, you can just stick in that extension to this library and you don't have to change any of your other code. That's the goal, is to try to make it so that you can take parts out, put parts in, and you don't have to rewrite your entire code base. So fast refactoring is also a goal by using these interfaces. Data table is a means to storing data in a table. Date time functions, these are built on top of your C times, so you can do local things for your current offset from Greenwich Mean Time, or you can do UDC, and you can see it's pretty straightforward. Get your seconds, your minutes, your hours, whether 12 or 24, whether it's AM or PM, day, month, year as 2 characters, year as 4 characters, whether or not you're on daylight savings time if your country does that. So just a way to interact with that. Dictionaries are built on top of unordered mappings, but they allow you to access information in a rather easy way. You can add to them, you can remove by keys, you can check if a key exists. So again, just trying to make life easier to interact with. C++, generally, there's a lot of really nice classes, but the classes often feel like they're plain old data types where they're structs basically that hold all the data you need, but then you have to remember all of the magic little functions that are out there that work with them to do the things that you want. And if you use it over and over and over, it's second nature. You know to type in exactly what you're looking for, you pass it in, and everything works fine. I wanted to try to take the approach where, since IntelliSense is built to the Visual Studio Code, that you can hit period or the little arrow symbol for a pointer to dereference it, and it pops up a list of all the things you can do. I just personally find that handier. Exceptions. I also use try, catch exceptions. The goal of this library is to also manage a lot of the memory for you. So the use of exceptions, I like them. I like to know when things go wrong, why they go wrong, why it's going wrong. There's, I'll have a video on that, but there's this little macro for exception parameters automatically passing your file name, the line number, class, which is not a default thing. Talk about that later. Function, so that it gives you the most information to help you debug. Easy debugging is a goal as well. Now with naming, the naming that convention that I have used for this toolkit specifically is namespaces are all lowercase. Classes are uppercase first letter, so I guess, and if there's multiple words, then it's technically called like Pascal case. And then the methods themselves or member functions are camel case unless they're a static method or function or whatever. Then they're also in Pascal case. So essentially, if you're about to type something with an uppercase character, it probably needs to be preceded with colon, as opposed to a period or a dereference arrow. So I tried to lay this out in a way that the naming helps you know what's going on. The other thing that you'll see is if it asks for a pointer, so anything with little asterisks, or if it gives you a pointer, generally that means that you control that memory or you're handing control over. So if it asks for a pointer, you're probably handing over control to the library and you don't have to worry about it anymore. The pointer will be automatically deleted when it needs to be deleted. If you are given a pointer, then you now control that. And if it asks for a reference, that means that control's not being handed over. And that's just sort of the approach I've taken on this as well, to try to make ownership as clear as possible. File reader, we already talked about that a little bit. This is the concrete class for stream reader. There's file writer as well. File system, there I'm sure will be more of these in the future as well. So your path separator, which is set based on your OS, whether it's a / or a backslash. The ability to copy a file, create a directory, delete a directory. Things for working with files and folders, basically. Getting a file name out of a path. Getting a file name without its extension, just getting the extension itself. Whether or not it's a directory. Basically all the things you need when you're working with a file system. Internal. This is an interesting aspect that I may need to work on a little bit more. When you start inheriting multiple layers, there might be problems there. So like I said, this is under development. The idea of internal is that if you're working with inside of a library or something that you're developing yourself, if you use internal, it will be public, basically, so that you can interact with it. And then if you reference it from an external class, it will be marked as private so that you can't accidentally call information you only want. It's similar to the C# version of internal. I don't remember the name for Java, but it has it as well. It's called like private class or class private or something like that. So it exists in multiple languages. Um, I like the name internal. It seems to help explain what it is. If that feature goes away in the future, it might, if I can't figure out some of the idiosyncrasies of it, or it might stick around. Like I said, under development. And this video is getting long, so I need to start picking up the pace. Logger is designed so that you can throw debug messages and with different levels of warning. And for each level, you can set it to either write to a file, write to the console. In the future, there might be an email reader, email writer, so it'll automatically write an email for you. These are some long-term goals I have. So yeah, there's that. You have all of your math functions. Cool. Primitive is sort of a unique class. Mainly if you want to store, if you have an array and you want to store objects into it, you can't store integers or doubles or floats or things like that because they don't inherit from object. So this is a way to make primitive types inherit from object. That is its sole purpose. Do I see it being used a lot? Not particularly, but if you ever need it, it's there. Signals, we already talked a little bit about. Singletons, yes. So what the singleton class does is if you want to create a singleton and you want it to automatically destruct itself when your program is ending, it will automatically call your destructor. Generally, you might not need it to clean up memory because your program is ending, so the memory will get cleaned up by the OS. Unless you're writing on bare metal and you don't have an OS, then that might be a good option. However, then the standard library probably won't work, so yeah, that'd be interesting. But anyway, if you are using a library that, let's say, I don't know, ncurses, you have to change the way the terminal works, and then when you're done, you need to change it back again. Singleton might be a good example usage for that, where when it's constructed, it sets up your terminal the right way, calling all the appropriate ncurses functions, and then when you end your program, it will automatically call the destructor, and the destructor will say, set everything back to the way it was, so that, for instance, if you move your mouse on the virtual terminal, it doesn't spit out a bunch of wonky characters at you and escape codes or things like that. So this is a way to have a singleton and make sure that the destructor gets called when the program is ending. Singleton manager is what makes that mechanism work. Smart references are kind of like smart pointers. They hold a pointer in them, and then you have the ability to get a reference out of it. So when this container is being destructed, it will automatically delete your reference. Notice I said the word delete. It will delete your reference. It will not free it, or your pointer. It will not free it. So if you're using mallocate and free, don't use this. If you're using a C++ class and you're using new, this will automatically do the deletion for you. And so it's kind of like a smart pointer, except it allows you to get a reference so that you don't have to dereference your pointer over and over and over. And part of that also is, like I mentioned earlier, with the permissions or the ownership, the idea being when you pass over a pointer to the library, you're giving over its ownership. So this is to follow that methodology so that if you're working with a reference, you know that you're not giving over ownership and things like that. Tree node is to build nodes into a tree, and with the sister library or sister toolkit, Pyramid, that's being developed currently, which is a GUI framework. That will probably use tree nodes more, but I have run into instances where having trees are helpful in command line programs and things like that. Tuple, this is just built on top of the tuple library. Again, it's hard sometimes to remember what get means because it's sort of weird, or tie of how the variables are working inside your tuple or whatever. Yeah, this library is kind of for people that use C++ and then walk away from it for a while and come back and look at it and go, what on earth is going on? Because I've been that person. So this is kind of like my memory now. It IntelliSense or whatever tells me what I'm trying to do, and it remembers which C++ functions need to be called to make that happen. Type array. Yes, this is sort of an experimental thing. It's the ability to store types into an array, and then as long as you remember what index that is, you're able to get type information. Because C++ classes, when they're compiled, don't store any metadata. So you can't do reflection, you can't do anything like that. And the goal with this was to try and save the type information so that you can do some things that normally would be very much more challenging to do. Definitely experimental though. And then XML reader and writer, that's for taking XML files and being able to parse out data out of them. So that's a rundown, not super quick rundown, but a rundown of all of the current things that are implemented. And like I said, some of these might go away, some things might get added, but hopefully it just kind of gives you a feel of how this toolkit is expected to work, whether or not you would be a target user based on your requirements of what you're working with. If it's something you would enjoy working with, great, use it. If it's something you don't enjoy and you think it breaks the spirit of C++ or whatever, which is the spirit of a challenging learning curve and things like that, okay, don't use it. Yeah, it's up to you. You have a brain. If you're programming, I hope you have a brain. Otherwise, you're going to be writing horrible code. So use that to determine whether or not you would like to use this library. So I hope you found this informative, and we look forward to seeing you in the next videos.